In this lesson, we are going to be talking about identifying transformations in tessellations. So when we have a tessellation such as this one here, we can actually choose one of these shapes and get each of the next ones by using the transformations we've started learning about at the beginning of this section. So if we're going to use this shape, we're going to start with this shaded purple one. And we are going to take and think, what do I need to do in order to get each of the subsequent shapes or each of the next shapes? So if I start with the shaded one, to get shape A, I am going to reflect over this line. And so when I flip it over that line, I'm going to get shape A. Now to get shape D, I would also reflect, except for I would use a different line of reflection. So if I reflect it downwards, I'm going to get shape D. So this is also going to be a reflect. Now, to get the shape that goes in here, shape E, I can reflect shape D. So you can see that we are doing a lot of reflections in order to get each of the shapes. Now, we can also get them in other ways. So for example, to go from the shape here to shape F, I could translate it over and down. I could rotate to get to shape C, or to shape D, I could rotate on this point here. So as I go through, I can get each one of these by using each of those transformations that we talked about in the first section of our unit. Under each transformation, the area of the shape doesn't change. So we talked about that the shape doesn't stretch, it doesn't get smaller, I didn't twist it. And so that area of the shape does not change. This is known as conservation of area. This means that all the triangles in the tessellation will have the same area. Sometimes a tessellation may be described by more than one type of transformation. So if I'm looking at this tessellation and I am looking for a translation, there are lots of options here, but I might just say that I would like to start with this diamond here, quadrilateral, and I could say that I'm going to translate it, and this is going to become my image. So I'm going to take and I'm going to move it to the right. So that would be an example of a translation. If I want a reflection, an example of a reflection would be, maybe I'm going to start with this shape here, and I'm going to reflect it over this line. And when I do that, I am going to end up with this shape here. In terms of a rotation, I might say that I'm going to start with this shape and I'm going to rotate it around this point. Now, when I rotate it around, I'm going to end up getting this shape. When I take an I pin this corner and spin it around, I'm going to end up with that shape. So this is an example where we can use all three of the different transformations in order to get our each of the shapes in our tessellation. So in this tessellation here, we also have a combination of transformations. So if our first shape is going to be this one here, I can look and see a few different things. Now, to go from this shape to this one, that would be a translation. So if I want to talk about going to this one here, that would be a translation. Because I am picking it up and I'm moving it over here. Likewise, I can start with this one here, and if I rotate it around this point, I'm going to end up with this shape. So in that case, I would have my rotation. Now, this situation does not have a line of reflection. So no matter where I go, I'm not going to have any sort of reflection, so that is not going to be one of the transformation in this. Now, when I'm looking at this, the next question asks, how do I know that the area of the shape is conserved? Or how do I know that the area of each one of these shapes is the same? Well, there's a couple of different ways. We know that in a tessellation that the shapes are congruent or they are the same. So congruent is the fancy math word for same. Or another thing that we can do, which is a little bit more literal, is we can actually count the boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This one and this one combined would give me 15, and those two combined would give me 16. And if I count each of the shapes, I know that each of these shapes is 16 units squared, or 16 little boxes there. And so I know that the shape has been conserved. Now, I know you don't have the textbook to have the assignments. If you want to go on to Pearson Portal and do that, you're more than welcome to. Or you can do the questions that I gave you in your notebook to go home. If you have any questions, please send me an email or hit me up on Google Hangouts and we can set up a time to meet.